Alright, so let's look at what we're going to do today. We're still going to be factoring polynomials, but now we're going to be looking at this form called ax squared plus bx plus c. We're going to now have an a value that's not 1. Remember last week you just worked with polynomials that started with x squared. Well, now you're going to have something, a coefficient in front of the x squared. No problem. We're still going to do it the same way. There just might be more choices as we're looking at the factorization. So let's look at this and think about how we can do this. So we've got this trinomial and we want to factor it. I'm going to start by doing what we did last week. I want to think, alright, how can I make two binomials that I can multiply together to give me 3x squared plus 16x plus 5? Well, your first term is 3x squared. So your first term for each binomial is still going to be a factor times a factor that will give you 3x squared. So instead of x times x, I can now write 3x times x because that will give me x squared, right? And now for the last term, I want to think about factors of 5 that when we multiply, we will get a sum of 16x. Well, look at the signs like you did last week. It says plus 5, so the only way to get positive 5 is to either make both of these negative, minus times minus, or to make them both positive. Well, look at the middle term. The sum of the two terms has to be positive 16, so the only way to get positive 16 is if you add a positive and a positive, so we know that it's going to have to be plus and plus for both binomials. And now just think about, what are the factors of 5? What if I put a 5 here and a 1 here? And now, if I look at the 5 times x, we get a 5x. And if you look at 3x times 1, you get 3x. And look at that sum. Does 5x plus 3x give you 16x? No, it doesn't. So we know we need to change it. What if we try? Try it again. This is how you get it. To get 3x squared, we don't have to change that because the only way to get 3x squared is 3x times x. But notice now, if you change the order of this 5 and 1, it's going to give you a different sum of the two terms. So what if I try making this 1 here and making this 5 here? Now what do you notice? 1 times x is 1x, and 3x times 5 is 15x. And what do we have? 1x plus 15x is equal to 16x. So we know then that this is our correct factorization of this. And if I were to multiply this all out to check it, you could do 3x times x is 3x squared, 3x times 5 is 15x, and then distribute the 1. 1 times x is 1x, and then the 1 times 5 is 5. Combine your like terms, and you get 3x squared plus 16x plus 5. So you know then that this is the correct answer. Alright? Try this one. 4x squared plus 24x plus 11. What do you notice about the 4x squared? Is there only one factor of 4? You can multiply 4 times 1. You can also multiply 2 times 2. So this is where the more choices come into play. Well, let's just start. It doesn't matter what you start with. Let's just start with 4x and x. That gives you 4x squared. Look at the signs. Plus 11, plus 24. That's your clue telling you that both of these have to be positive. And now just think, what are the factors of 11? Well, what if I do 11 and 1? And now if I want to check it, 11 times x is 11x. 4x times 1 is 4x, and if you look at the sum of those two terms, 11x plus 4x does not give you 24x, so we know that one's not right. No problem. Try it again. Let's stick with 4x and x, but instead of putting 11 here and 1 here, let's change the order, and we're going to see that that will change the terms. Well, now 1 times x is 1x, 4x times 11 is 44x. That gave us a different sum, but it's still not the 24 that we're supposed to get. That would be 45, so that one doesn't work. No problem. You can't change the factors of 11. They're 11 and 1, but notice you can change the factors of 4x squared. So what if we try 2x and 2x? 2x times 2x gives you 4x squared. So that'll give us some different possibilities. Still going to be plus and plus. Well, since these two terms are both the same, the order is going to give us the same answer. What happens now? 11 times 2x is 22x. 2x times 1 gives you 2x. The sum of those two, 22 and 2, gives you the 24. So we notice then that this is our correct answer. And if you were to check it, multiply 2x times x, that gives you the 4x squared. 2x times 1 is 2x. 11 times 2x is 22x. Combine those to get the 24x, and then your 11 times 1 gives you the plus 11. You can check it and know that you're right. And then on the last one we're going to look at, you still want to think, all right, what are two binomials? 3x and x. That's easy because the only factors of 3x are 3x and x. Now look at the signs. We need to get a positive 4, but we need the sum of them to be a negative. Well, the only way to do that would be if we did a negative times a negative to get positive 4, and then when we add those two negatives, that'll give us a negative 8. So we know already that we're going to have 3x minus and x minus. We'll now look at the factors of 4. Factors of 4 could be negative 4 times negative 1. And then if you check that, negative 4 times x would be negative 4x. 3x times negative 1 would be negative 3x. Well, when you combine those, you get negative 7x. It doesn't match the negative 8x, so that one's wrong. What if we tried it and just switched the order of the 4 and the 1? What if we made it 3x minus 1 and x minus 4? That'll give us different terms. Negative 1 times x is negative 1x. 3x times negative 4 is negative 12x. Add those two together and you get negative 13. That doesn't match the negative 8. No problem. Remember, we said think about factors of 4. Other than 4 and 1, you could also use 2 and 2. So what if we did that? We're still going to use 3x and x. That's all we have there. And now what if we do minus 2 and minus 2? And what do you notice? Negative 2 times the x gives you negative 2x. 3x times negative 2 gives you minus 6x. When you add those two together, that gives you the negative 8x. That one works, so we know that this is the answer. So it's the same as you were doing last week, you just have more choices to consider. So don't be afraid to try until you find the right answer.